Swayam Prabha. Digital India. Educated India.
Morning. So we have seen that spherical wave and linear wave propagation, and we have derived that intensity equation I. Intensity is nothing but a p square by 2 rho 0 c. So that is the rho 0 is the density and c is the velocity of the sound, p is the pressure of the sound. So intensity we derived, and also we seen in spherical wave propagation, if the wave is propagated in spherical nature, the intensity of the wave depends on the radial distance r. So it is p, since the p is nothing but a p by r, so p square is nothing but a, so it will be p square by 2 rho c into r square. Okay. So if it is distance is large, then the intensity will fall down for the spherical wave propagation. Now another thing is that when we heard the sound, okay, one is that sound is propagated, it may be audible, it may not be or not audible, the frequency may be different. So those kinds of issues are there. But if you see, when you developed any technology, whether it is sound, whether it is vision, any kinds of technology, when we develop for human perception, like microphone, like loudspeaker, music systems, it is basically developed for human perception. Now we have to know how human is perceived the sound. If I know that, then depending on the human perception, I can play with the technology, so that suppose that I want to I have raised that volume of that amplifier. If you seen it, there is a loudspeaker is playing in let us say in auditorium. If you raise the volume, are we perceive the, if I raise the volume double, are we perceive the intensity which I perceive by the human being is also be a double? If it is not double, then what it should be it is. So the perception of sound is also an important parameters. I am not going details about the perception of human perception, but perception of sound I little touch upon here, so that you understand when we are playing with the technology, frequency, intensity, we should also know how it affect in human perception. Okay. Now if you see how we perceive the sound, if you see the slides, we perceive the sound. Basically we have a sensor, sound sensor ear. So we have a ear has a 3 part, one is called outer ear, this is outer ear, if you see this is called pinna, outer ear, middle ear and inner ear. So inner ear is basically connected to the nerve and that sensation going to the brain for perception. Outer ear is the pinna, external canal, and middle ear is the, you know that membrane, and this kind of arrangement is there. Details you can see in any internet or any books, that this is the human voice. So once the sound acoustics inter air, suppose you have play a sound box in this room, the sound intensity will fall on this pinna. Now you know if the intensity is I, then what is the energy? Energy is nothing but a I into area. So if the area of the pinna is increased, then your intensity, your energy, acoustics energy received by the ear will be increased. That is why sometimes if there is a low intensity sound, we place our hand in here. What we are doing? We are increasing the acoustics energy, which is supposed to go inside the ear much, because I put a more area in here. So I just, if I put a area in here, that intensity will be common here and total area will be multiplied, and that much of acoustic energy will be go inside my ear. So that is the work of the outer ear, this is called pinna. Then what is middle ear? If you see in the middle ear, there is a 2 kinds of bone and 1 membrane. This is, you know that this is called that membrane, one membrane is there. So, once the acoustics energy pass through the canal, then there is a vibration is created in the membrane like a float. Vibration is created in the membrane. Once the membrane is vibrate, that vibration is transferred through a bone conduction to the inner ear. So, that is the human perception things. So, outer ear, middle ear and inner ear, those are the three main part of human perception. Now, if I see that schematic diagram, so it is nothing but a pinna, auditory canal, then there is a membrane, then there is a bone structure which attached with the cochlea, which is the semi fluid liquids are there for human perception. Now, I am not going details. So, acoustics intensity will be gathered by the pinna, converted to the vibration by the membrane, then transferred through the bone to the inner ear. So, if before that inner ear, if I see that that how it is look like, that response, there is one kind of, you know, every system has a frequency response. So, it is said, it is experimentally proved that the frequency, if I prove the frequency versus outer ear gain, how much the frequency response of the outer ear, this pinna is like this way, if you see this curve. So, all the frequency are not equal sensitive, there is some frequency, outer ear is much more sensitive. Okay. Then there is a middle ear frequency response curve. So, if I convert that to combine the outer ear and middle ear, the response curve will be look like this. Okay. Response curve will be look like this. So, this is the frequency scale and this is the response in dB. What is the meaning of this curve? If I want to explain the meaning of this curve, if you see the sensitivity of the middle ear and outer ear is varies according to the frequency. If you see at the lower frequency, sensitivity is less, at the higher frequency gain is very high. That means, low intense sound within this frequency range I can hear same intensity like that. Suppose this is 0 dB, or let us 0 dB of 1 kilohertz sound and 0 dB same intensity dB of 20 hertz sound. I cannot hear this 20 hertz sound, but I can hear that 0 dB of 20 kilohertz sound. So, this is there is a connection, that just if I say the efficiency of my ear is nothing but a reverse of this curve, efficiency of this ear is nothing but a reverse of this curve. So, I will come to that point, I will come on. So, if I say that auditory, or you can say the sound perception is a human phenomena, but sound is a physical phenomena. Sound, you can see the sound wave is travel in the air, sound wave travel in this room. So, this is a physical phenomena, but perception is a behavioral phenomena by a human being. So, I can say sound or auditory has a two dimension, one is called perceptual dimension, another is called physical property of that sound. So, if you heard that you know that perceptual dimension are pitch, loudness and timbre, and physical dimension fundamental frequency, intensity, spectrum or envelope or composition of that sound. Okay. So, what is the difference? Physical phenomena I can measure, but in perceptual phenomena I can only observe. So, if I say that okay, intense, what is the difference between the loudness and intensity? If I say a microphone speaker produce a intensity of 60 dB, I know there is a value of intensity, I can measure it physically. So, that is the physical properties. Or if I say this sound is louder than the previous sound, that is my perception. This is my perception. After hearing the sound, I thought that this sound is louder than the previous sound. So, this is a perceptual dimension. So, that can be observed only. Similarly, you heard about that pitch and fundamental frequency. Pitch is a perceptual dimension. What is pitch? If you see, if I play the same node means same fundamental frequency of a setar, harmonium or guitar, even if you close your eye, you can identify which instrument are producing which sound, but fundamental frequency is same. So, pitch is a perceptual scale, is a perceptual parameter, but if I say the fundamental frequency which can be measured within that speech is a physical parameter. So, this is the difference between the perceptual parameter and physical parameter. Similarly, visual dimension also, you know that hue, brightness and shape and wavelength, luminance, color, contrast, all you know that. This is the auditory, this is the visual and this is the auditory. Okay. Timbre I am not explaining. Now, if I say why I have to know this all kinds of perceptual things? Yes, because if we studied the sound system engineering, let us I give you an example. Pollution Control Board said that 60 dB should be the sound limit for maintaining the environment pollution. I cannot produce a sound which is more than 60 dB because it may harm to the human being. So, now 60 dB, what do you mean by 60 dB? I write 60 dB. What is the meaning of that 60 dB? 60 dB is nothing but an intensity. I said the intensity of the sound must be 60 dB. What is the meaning of the dB? Everybody is known dB is nothing but a 10 log output by input. You know that? That output by input 10 log 10 is the dB. Okay. Now, if you say Bell, Alexander Graham Bell had said that in case of sound, one bell means log I divided by I rep. What is I rep? Is the reference sound of human being. What is the reference sound? The intensity of the sound for which I just heard the sound is called I rep. Okay. So, at I rep, if I equal to I rep, then it is nothing but a 0 bell, 0, there is nothing but a 0. So, what is it? dB, decibel. What do you mean by deci? Deci means tenth, deci means tenth. So, decibel, deci, bit I said deci, deci is nothing but a 1/10. Okay. So, decibel. So, 1 bell is equal to 10 decibel, 10 decibel. Okay. So, I multiply this decibel, it is 10 log 10 input output by I reference. What is I reference? I reference is the intensity of that sound for which a human being can just normal audio spectrum of the human being, normal human being can just hear the sound. Okay. So, in the value that reference value that 0 dB, so that is called 0 dB. So, I rep is nothing but a 0 dB because rep is 1. So, it is nothing but a 0 dB. So, 0 dB of sound is that sound of intensity of that sound for which a human being can just audible of that sound. I just heard that sound. A normal human being can just hear the sound, which is called 0 dB. So, 0 dB is nothing but a 10 to the power minus 12 watt per meter square is the I reference for normal human being. If I produce 10 to the power minus 12 watt per meter square intensity, then that sound is just audible. Now, there is another thing. Is this power I should be for any frequency? I just said the frequency response of the human ear is not linear, it has a change with response to the frequency. So, it is not 10 to the power minus 12 watt per meter square intensity cannot produce a sensation for different frequency. Only for 1 kilohertz frequency, if the pure tone is in 1 kilohertz sound or sound frequency is 1 kilohertz and intensity is 10 to the power minus 12 watt per meter square, that sound only can produce a sensation for a normal human being, means which is just audible. So, for different frequency, the amount, this I will be different. Okay. So, that is why we make a curve. If you see this curve, this is called threshold of hearing. That means, if I produce a 60 dB sound of let us 20 hertz, then it is just audible. Okay. But I can audio the 1 kilohertz 0 dB sound will be audible for 1 kilohertz. So, if I say, if I produce a sound of 5 dB sound of 300 hertz and 5 dB sound of 1 kilohertz, which will be louder? In case of sensation, 1 kilohertz, because the frequency response sensitivity of my ear at 1 kilohertz is much higher. So, I can hear the sound is louder. Okay. So, loudness, when I say the sound level or loudness of the sound is a perceptual parameter, but when I say the intensity of the sound is a physical parameter. I can measure that intensity of the sound, but loudness is a perceptual parameter. Okay. So, loudness is a perceptual quality that is related to the physical property of sound pressure level. Now, I want to correlate the loudness versus sound pressure level or intensity of the sound. So, loudness is quantified by relating the actual sound pressure level of a pure tone in dB to the perceived loudness of the same tone over the range of human hearing. So, if I say this is the frequency response, this is the sound pressure level. So, this curve, the each black line is the same loudness curve. That means, if I travel along across this curve, if I change only the frequency, if I produce, suppose for 20 hertz, I produce a sound for 90 dB, and if for 1 kilohertz, if I produce a sound of 90 dB curve, if you see the 90 dB curve, around 40 dB will be equally loud. So, that is why this each curve is called phone curve. Phone curve, each line is a equal loudness line. Okay. Then loudness in term of intensity, I can convert. L is nothing but a, so this is you can see these slides and you can see that mathematical deduction, which is loudness converted to the intensity. How did it done it? It is very simple experiment. Suppose you put a loudspeaker on for a particular frequency, let us for 1 kilohertz, then you produce a sound, let us you produce a sound for 5 dB. Okay. Then you increase the volume, increase the gain, then you produce a sound of 6 dB, 7 dB, 8 dB, 9 dB, and you told the listeners, when you perceive the sound is loudness is double than the previous, you raise your hand. So, what you will get, that you are saying this is the loudness curve, this is the loudness level, and this axis is the intensity I. Okay. So, loudness level in phone. Phone means for a particular frequency, let us for 1 kilohertz sound, I produce a particular intensity I. Okay. Then I said, okay, this is my I. Now, I said the person that when you perceive the loudness is double, you raise your hand. So, let us once I increase the loud intensity, person raise his hand like this way. So, then I get a curve. That curve indicate the loudness, perceived loudness of that person with relation to the I. So, that is why the curve is represented like that log L loudness is nothing but a 0.033 sound level intensity minus 40. This is the curve they experimentally find out and put this equation. Now, you put that LL in dB and you find out that relations. Okay. Now, there will be several kinds of things that I reference for human being is 10 to for 1 kilohertz 10 to the minus 12 watt per meter square. It is I. Then what is the P reference? So, I reference is nothing but a, if I say I reference, so I reference is nothing but a P reference divided by 2 rho c. If I know the velocity of the sound and density of the medium, then I can calculate what should be the P reference. Okay. If you see this table, I have said the P reference for air, it is I reference 10 to the minus 12 watt, P reference is 20 micropascal, we will use it. So, when we convert pressure in dB, let us I say I produce a 1 Pascal pressure. What is the dB in term of human perception? So, it is a 1 Pascal means 10 log 1 Pascal divided by the P reference. What is the P reference? Pascal divided by 20 micropascal. So, now I convert this thing and find out the how much dB is the sound. So, providing a sound level pressure Pascal in Pascal, I can convert into dB by the using the P reference for air. Similarly, if the sound is propagated in water, then water is 1 micropascal, reference is 1 micropascal. Then if it is water like 1 Pascal, then it is 10 log 1 Pascal divided by 1 micropascal. P reference will be different. Okay. So, this kind of calculation will be used many times in our tutorial and other things. This is for your information, if you can get it from anywhere, jet plane, that intensity and sound level. So, sound level means pressure level. So, it is intensity means I, it is nothing but a P. So, I is 100 dB, sound pressure level is 140 dB, pain of threshold, then all things you can get it. Okay. Then there is another example, that how do you convert the dB, and this is nothing but a mathematics, simple mathematics. Suppose somebody said that some percentage change, how it is converted to the dB. So, percentage change is nothing but 100 into 1 minus 10 to the power minus dB divided by 10. If it is decrease, if it is increase, then 10 to the power plus dB divided by minus 1. Similarly, percentage to dB and dB to percentage. So, this equation you can remember and then use. Like let us do this kind of mathematics. An anechoic chamber absorbs 90% of the power and reflect only 1%. What percent of initial sound pressure level is reflected? So, this kind of question may ask by the society, that an anechoic chamber I have designed, and it is 90% of the power is absorbed and reflect only 1%. So, what percent of initial sound pressure level is reflected? So, let us Wi, if you see that Wi is equal to 100 watt. If I produce a 100 watt sound, so reflected power is 1 watt. 99% is absorbed and 1% is reflected. So, if it is 100 watt, then I said 10 log 100 divided by 1 is equal to 20 dB. 100 divided by 20 dB. So, it is nothing but a 99%. So, percentage change is nothing but it is decrease. So, it is nothing but 100 into 1 minus 10 minus 20 divided by 20 is equal to 90%. Okay. So, the reflected sound pressure level SPL, reflected sound pressure level will be 10%, 90% of the sound pressure level is absorbed and 10% is reflected. Okay. Similarly, you can do for other mathematics, for other kind of things, that if it is 5%, if suppose somebody said I play a loudspeaker and its gain is raised by less 3 dB, you do it in home. I say the gain is increased by 3 dB. How much sound pressure level will be changed if I heard it? Percentage change of the sound pressure level in perception. You can convert it. Okay. So, this kind of mathematics will be done in practical cases. Will be use this kind of frequency mathematics, dB to percentage to dB, and convert that sound in dB. Similarly, somebody can say, okay, I have a, somebody asks you that, okay, pollution control board said that I cannot produce a 60 dB, more than 60 dB sound. So, if I want to limit the sound pressure level 60 dB, what should be the output power of my amplifier? Limit of the output power of the amplifier. So, if I say convert these two in what I can convert? How much? If I want to produce a 60 dB sound, then how much energy is required? So, I reference, so it is nothing but a 60 dB is equal to 10 log I divided by I ref is 10 to the power minus 12 watt per meter square. So, from there I can calculate I, how much wattage I require to produce that sound. Okay. Similarly, if I say I have an amplifier, I have an amplifier with a gain of, let us 10 dB is the gain of my amplifier. I want to restrict the amplifier to produce only 60 dB sound. What should be the maximum input voltage to the amplifier? So, gain is 10 dB. So, I am to produce 60 dB. So, input is 6 dB only. So, 6 dB I can convert to the reference. With respect to reference, I can convert to how much power is required. So, similarly, this sound pressure level I can also say, if it is dB is, if it is in air, I value of I is given 3 watt. What is SPL? SPL means sound pressure level. If I air, rho and C will be given, then I know I, and then I can calculate P, because I is equal to P square by 2 rho C. So, I can calculate P. So, those way we can calculate, do the things, many things we can do. I am not going details to the frequency perception by the human being, because that is not included in here, but yes, you can you have to know it, you can read it from other sources, because frequency response is also. So, why that will be there? Why I do not require a flat frequency response of an loudspeaker? Because human perception of the frequency is not flat. We are not perceive the frequency linearly. If I produce a sound of 100 hertz pure tone, and then I produce a sound of 100 and just 1 hertz, a human being cannot distinguish between these two sounds. A human being will say the two sounds are same, but physically they are different. So, the human perception of the frequency is also important. That scale is called male scale or Bach scale. You can say the Bach scale is the Bach scale or male Bach scale, that is there. Bach scale, male scale is there. So, if you wanted, then I can, if you raise some questions on this area, I can take another class on frequency perception of the human being. Okay. So, but you should know that what is dB and how it is converted. So, those kinds of things I will deal with some tutorial, I will give some assignment. So, where you can find out. So, then if somebody asks you what do you mean by 0 dB sound? 0 dB sound means intensity of the sound is 10 to the power minus 12 watt per meter square, and SPL is, if in case of air, 0 dB in air 10 to the power minus 12 watt per meter square for 1 kilohertz pure tone. Okay. Similarly, in that case the pressure SPL is nothing but a 20 micropascal. 20 micropascal for 1 kilohertz tone, but if it was a 20 hertz tone, 0 dB may be shifted to somewhere else. So, for the low frequency, we perceive our efficiency of the ear is very less, and also high frequency efficiency is less. So, that is why our ear, if you see that this is the curve for hearing. So, if you see the low frequency threshold of hearing is high, high frequency also threshold of hearing is increases. At the mid range frequency threshold of hearing is very good. So, that means we can perceive, we can differentiate between that 1 kilohertz, this slightly higher frequency, we are very perceptive, means we are very sensitive of the intensity of those frequency. Okay. So, at high frequency very large amplitude has to be produced to heard it. Low frequency very large amplitude has to be produced to heard it. So, somebody may ask you, suppose I produce a pure tone of 300 5 dB pure tone of 300 hertz and 5 dB pure tone of 1 kilohertz, which will be louder? 1 kilohertz. Similarly, somebody can 10 dB pure tone on 2 kilohertz, 10 dB pure tone on 10 kilohertz, which one will be the louder? 2 kilohertz will be louder. Okay? And the curve, frequency response curve of the ear, that equal loudness curve, if I go through this direction, equal loudness will be equal, that is called phone curve. This is the equal loudness curve. Okay? And this high frequency also it will be increases. It depends on the human perception. I am not going many details of that things. Okay? So, then we will do some tutorial and it will be completed. Okay?